Hello students, in this video lecture we are going to study about solution of linear differential equation. In fact, we are going to study the solution of first order linear differential equation. So in this video lecture, what I have planned to discuss is about the definition of ordinary differential equation, types of first order differential equations, definition of linear first order differential equation, and how we are going to solve this, that is the method of solution, then algorithm, which is the step-by-step process to obtain the solution of first order linear differential equation, and then we are going to apply this procedure or the algorithm to solve some examples. At the end, we will have some practice problems. Before we start up with linear differential equation, first of all, it is very important for us to understand what is an ordinary differential equation. So as the name itself says, it is ordinary differential equation, which simply means that this equation will have ordinary derivatives rather than the partial derivatives, which we are going to study in our higher classes. So here we already know what is an equation is. So here this equation is something special because it is called as a differential equation. Why is this? This is because it contains some derivatives, first order, second order, or maybe higher order. So what is the definition of ordinary differential equation? An ordinary differential equation is an equation. Of course, it is an equation. We all are familiar with the equations now. So it is also an equation, but it will be involving independent variable, which is usually x, dependent variable y, and its derivatives. So for example, how will you write if you want to write a general ordinary differential equation? It is a function of x, comma y, comma y dash, y double dash, and so on. Y to the y nth derivative of y is equal to 0. So you can see in this equation, there are some variables in which x is known as the independent variable because x does not depend on anything, whereas y, which is a function of x, depends on x, therefore y is a dependent variable. And then on we have y dash, y double dash, and so on, which are nothing but the first, second, etc. and the nth order derivatives of y with respect to x. So if you have such an equation, this equation is known as ordinary differential equation. So this is all about ordinary differential equation. Now, if we want to know what are the different types of ordinary differential equations we have, usually we will have linear differential equations, which we are going to study now, variable separable form, homogeneous differential equation, and exact differential equation. Or some of them which are like they are convertible to linear differential equation, or that is also known as reducible to linear differential equation, or some equations which are reducible to variable separable form, some equations which are reducible to homogeneous differential equations, and some equations which can be converted or can be reduced to exact differential equations. So most of the differential equations that we come across will fall under any one of these categories. Either they are these four equations or they are reducible to any one of these four equations. So now we shall look at specifically the topic of interest, which is the linear differential equation. In fact, we are going to study about first order linear differential equation. So what is this? The definition for a linear first order differential equation. So what is this? An ordinary differential equation of the form dy by dx plus py is equal to q, where p and q are functions of x, or they may be constants, or any one of them. P may be constant, q may be a function of x, q may be constant, p may be a function of x, both p and q may be functions of x, or both p and q may be constants. So if such a thing happens, then we call this as a linear differential equation of first order. As the name itself suggests, you can see that the derivative dy by dx, it is the first order derivative. Hence it is called as first order differential equation. And since it is in a specific form, which is dy by dx plus py is equal to q. Therefore, it is a linear differential equation of first order. So, is it the only way that we express the linear differential equation in this form? No. We can have even the linear differential equation may be in the form dx by dy plus rx is equal to s. So, you can see here, instead of y being the dependent variable, here x being the dependent variable. So, in the earlier what we have written in equation 1, y is depending on x, whereas in the note what we have written here, x is depending on y. So, what you can see the change from equation 1 to this equation in the note. You just check what happens. You can see that there is exactly they are the mirror images. Like, see, y has been changed to x and x has been changed to y. They are interchanged. That means similarly here dx by dy plus rx is equal to x. R should be, r and s may be functions of y, or constants, or combination thereof, which means that, as I told you in equation 1, r and s both may be functions of y, both may be constants, or one is r is constant, s is a function of y, s is constant, or is a function of y. Any one of these combination is possible. So, how do you solve such an equation? So, to solve this equation, we use a factor which is known as integrating factor. What is this integrating factor? How we are going to get this integrating factor? Let us just look at this. So, to solve this equation 1, we determine the function of the independent variable x, say m of x. One function that we are going to find here is m of x, which is known as the integrating factor. We call this in a short form as if. So, for this, what we do is we multiply equation 1 throughout by m of x. So, what happens? What is this actually? What is that we are trying to do here? We will just unfold this as we go further. So, what happens now? What is our aim? What does this step say? It says that you have to multiply equation 1 throughout by m of x. So, just multiply equation 1, which was dy by dx plus py is equal to q. So, now multiply each and every term by m of x. So, now your m of x, you need to choose it in such a way that LHS of equation 2. So, we call this as equation 2 after multiplying equation 1 by m of x. Whatever the equation that we are going to get, let us call that as equation 2. Once we find this equation 2, what we have to do is we need to see to it that our m of x should be in such a way that the LHS of equation 2 is nothing but a derivative of y into m of x with respect to x. So, this is one thing that we have to take care. Only then it is easy for us to get our integrating factor. So, look at that now. What is that? We have seen that we want our m of x to be in a particular form. That means which should be satisfying the LHS of equation 2. So, which means that we are taking our m of x. Let us assume that m of x we have already chosen in such a way that LHS of equation 2 is nothing but d by dx of y into m of x. So, LHS of equation 2 you can replace by dy dx of y of m of x. So, that is what is equation 3. So, m of x dy by dx plus m of x py. So, that is the LHS of equation 2, which is now equal to m of x derivative of y into m with respect to x. So, just apply the product rule. So, m of x into dy by dx plus y into dm of x by d of x. So, by applying the product rule, we can get this term. So, now if you look at these two equations, we are saying that both of them are equal. Therefore, I can compare this equation with equation 2 and write what is my m of x into py. M of x into py are comparing. In equation 3, you just compare both LHS and RHS. You can write that m of x into py is nothing but y into dmx by dx. So, which you can simply rearrange and write it as dm of x by m of x is equal to p dx. Why is this? Because you can see that y is common on both sides. Hence, you will be getting with dm of x by m of x is equal to p dx. What we have done here is we have just taken the terms which contain m to one side and all the other terms to other side. Now you can see you can easily integrate this. Once you integrate this, what is that you are going to get is log m of x, because why is this? You can see here in that equation dm of x by m of x, it is of the form f dash of x by f of x. dm of x andre derivative of m of x. So it is like f dash of x by f of x, which is equal to p dx. So when you integrate f dash of x by f of x, you are going to get log f of x. So here in place of f of x, we have m of x. Therefore, you can get it as log m of x is equal to right hand side. We don't know what exactly is p, so we shall just write it as integration p dx. So now if you remove the log, you are going to get your m of x as e to the power integration p dx, which is nothing but the integrating factor, because we have said our m of x is nothing but the integrating factor. So you see here in throughout this, what we have done is we are trying to find our m of x in such a way that if you apply m of x, multiply the given equation by m of x, the LHS, that is dy by dx plus py of the equation, given equation, will turn out to be in the form d by dx of y into m of x. So if that, when you get that, it is easy to integrate. So now once we get e power integration p dx as the integrating factor, what is our problem? We need to get, actually we are supposed to solve the equation dy by dx plus py is equal to q. So multiply equation 1 now by e to the power integration p dx, because we know now what is our m of x. So once you multiply, you are going to get e power integration p dx dy by dx plus py e to the power integration p dx is equal to q e to the power integration p dx. So while getting the integrating factor itself, we have seen that we are going to choose our m of x in such a way that LHS of dy by dx plus py is equal to q, that is dy by dx plus py, which is the LHS, is nothing but d by dx of y into m of x. So what is m of x here? E power integration p dx. Therefore, this equation can be easily written as d by dx of y e to the power integration p dx, which is equal to, that means LHS of this equation is written as d by dx of y e to the power integration p dx is equal to q times e to the power integration p dx. What is that we have done here is we have used d by dx of uv, that is the product rule we have used, and hence we were able to write this. Now integrating both sides with respect to x, we get integration d of y e power integration p dx is equal to integration q e to the power integration p dx into dx plus c. What does this say? This is because we are integrating, we get a constant of integration. So once you can see that the left hand side is the total differential, therefore you will get it as y e to the power integration p dx is equal to integration of the right hand side. Since we don't know what exactly are p and q, therefore we shall just keep them as it is. As and when we solve the problems, we will be knowing what are our p and q, hence we will be able to solve this integral. So this will be the solution of the given linear differential equation of first order. So what is that we did in this procedure of finding the solution? We can summarize that in the form of algorithm, which is nothing but the step-by-step process to get the solution of the given differential equation. What is that we did first? We first have to see to it that the given equation is in the form dy by dx plus py is equal to q. Only then the process of multiplying throughout by m of x and then rearranging it in the form d by dx of y mx, all that will happen. Therefore, first write in the first step, just check whether your equation is in the form dy by dx plus py is equal to q, or otherwise put it in that form dy by dx plus py is equal to q. Once you have done that, you find your p and q. With the help of p and q from the equation that you have written, you write the integrating factor as e to the power integration p dx. Once you get your integration factor, you know what we did. We just wrote the solution as y e to the power integration p dx is equal to integration of q e to the power integration p dx with respect to x plus c. So actually this you can remember as y into integrating factor is equal to integration of q into integrating factor with respect to x plus a constant of integration. So of course where c is being written as the constant of integration. So these are the three steps to get the solution of first order linear differential equation. Let us now take up some examples. So let us solve this example. Solve dy by dx plus 1 by x into y is equal to x square. You can clearly compare this equation with dy by dx plus py is equal to q. And you can see that it is already in the form dy by dx plus py is equal to q. So you can easily get your p and q. So here comparing this equation with dy by dx plus py is equal to q, you know that p is 1 by x. So first step we saw that it is in the form dy by dx plus py is equal to q, and identified p, identified q also. Now it is our turn to find the integrating factor, which is the second step. So what is the integrating factor? Integrating factor is e to the power integration p dx. So with p is here 1 by x. So e to the power integration 1 by x dx. E to the integration 1 by x dx is nothing but log x. So e to the power log x, which is nothing but x. So what is the integrating factor here? The integrating factor here is x. What does the third step say? Third step says once you get your integrating factor, you can easily write the solution as y into integrating factor plus integration of q into integrating factor dx plus c. So just substitute your integrating factor what we have got along with p, q and whatever is necessary from the given differential equation. So you will get y into x is equal to integration of, here you can see q is x square. So just substitute that x square, and what is integrating factor? X dx plus c. And I have written there that it is q is identified here as x square. Now you just simplify. Yx is equal to integration of x cube dx plus c, which is a simple integration which all of us can perform. So y of x is equal to x to the y into x is equal to x to the power 4 by 4 plus c. Or you can simply write y as x cube by 4 plus 1 by x into c. So very simple process of getting the solution of first order linear differential equation. Once again let me remind you the steps. First step is write the given equation in the form dy by dx plus py is equal to q if it is not already in that particular form. Then second step is identify your p and q and find the integrating factor e to the power integration p dx. Once you get the integrating factor, you can easily write the solution as the third step, which says y into integrating factor is equal to integration of q into integrating factor dx plus a constant of integration. So this is the entire process of getting the solution for first order differential equation, linear differential equations. Let us take up one more example. dy by dx plus secant x into y is equal to 7. So this equation is again already in the form dy by dx plus py is equal to q. Therefore, you identify your p, identify your q. You can see here p is a function of x, which is secant x, and q is a constant. So once you know your p, you can write your integrating factor, which is e to the power integration p dx. So once you have p, just substitute that, perform the integration, get your integrating factor. So which is e power integration secant x dx, which is nothing but e to the power log secant x plus tan x. So integration of secant x is log secant x plus tan x, which gives you secant x plus tan x because e power log is there. So now you got your integrating factor. So what does the solution say? Once you know the integrating factor, how should you write the solution? The solution should be y into integrating factor is equal to integration of q into integrating factor with respect to x plus c. Since we have our integrating factor here as secant x plus tan x, we can write the solution as y into secant x plus tan x is equal to integration of 7 times secant x plus tan x dx plus c. So now the remaining process is simply to perform the integration and write the final solution. So y into secant x plus tan x is equal to 7 times integration of secant x plus tan x. So 7 times secant x. secant x integration is log secant x plus tan x, and then tan x is log secant x. So plus a constant of integration. So that gives you, you just simplify that, you will be getting the solution as log a plus log b is there. Therefore, we can write it as y into secant x plus tan x is equal to 7 times log of secant x into secant x plus tan x plus c. So this is how you need to find the solution. So all the three steps of the algorithm. First step, comparing with or writing it in the form dy by dx plus py is equal to q. Second step, finding the integrating factor as e to the power integration p dx. And the third step, which is writing the solution as y into integrating factor is equal to integration of q into integrating factor dx plus c. So this is one more example we are going to check now. Here you can see that this is not in the standard form. Cos x y dash plus sin x y is equal to 2 times cos cube x sin x minus 1. So this is not exactly in the required form dy by dx plus py is equal to q, but always we can try to write it in the given form or the required form. So you just write it in the form dy by dx plus py is equal to q. We can see that we get y dash is equal to, so what is that we need to do is we divide throughout by cos x. So when we divide throughout by cos x, we are going to get y dash plus tan x. Sin x by cos x comes, therefore tan x into y plus there is 2 cos cube is there. Therefore you just write it as 2 cos square x into sin x minus 1 by cos will come, therefore you just write it as secant x. Now this is in the form dy by dx plus py is equal to q. What is p here? P is tan x. What is q? Q is 2 cos square x sin x minus secant x. Though it's a very big term, but I think this integration should be simple. Let us check how we are going to do this. First step is over now. We have written it in the form dy by dx plus py is equal to q. Next step is we have to identify our p and q and then write the integrating factor. Integrating factor is nothing but e to the power integration p dx, and here p is tan x, therefore it is e to the power integration tan x dx, which is equal to e to the power log secant x. Once again your integrating factor will be secant x because we have e to the power log of a function of x. So second step is over. In the algorithm we had 3 steps. First step is writing dy by d in the form dy by dx plus py is equal to q. Second step is finding the integrating factor, and the third step is directly writing the solution using the integrating factor, which is y into integrating factor is equal to integration of q into integrating factor into d with respect to x plus c. So just substitute your integrating factor. Y secant x is equal to integration of 2 cos square x into sin x minus secant x into secant x. So in the place of q, I have substituted q. In place of integrating factor, I have written secant x. Remaining terms as it is. So y into secant x. Now multiply throughout by secant x. So there is cos square x and secant x. Therefore, cosecant can be written as 1 by cos. Therefore, you will be left with 2 cos x into sin x minus 1. Because therefore, you will be getting y secant x is equal to sin 2x minus 1, which can be easily integrated as y secant x is equal to cos 2x by 2 plus c. So these are some of the examples that we have discussed here. So now we shall just look at these practice problems. There seems to be a mixture of equation where they are in the form either dy by dx plus py is equal to q, or some of them are not in the required form. That means that we need to write them in the required form and then identify pq, find the integrating factor and then write the solution. Hope you have understood the procedure for solving the first order linear differential equation. So next we shall meet with one more video lecture on one more method of solving the first order linear differential equations. Thank you.